So let us discuss the third unit. So the third unit is and logarithms. So in this class, I will discuss about a logarithm. So logarithm was first invented by John Napier in the year 1640. John Napier is a mathematician who invented this logarithm. So this is a tool. Actually, we consider this logarithm as a tool which will be used to solve complicated problems, and they will be made into simple calculation part. So that's why we say that logarithm is a mathematical tool which will be considered or which will be used to simplify the complicated problems, right? Then what is logarithm? So as we know that, I will start from this. As we know that 2 to the power of 3 is equal to how much? It is 8. 2 into 2 into 2. 2 cube, that is equal to 8. So this will be called as power or index, and this will be called as base, and this is what? It is a number. 2 cube is equal to 8. So for simple purpose, for understanding purpose, so just please have in your mind, this is base, this is what? It is index, or we will call it as power, and this is number. Like that. For any base, if you put any power, definitely you will get some number. Okay. So the same thing we will consider in defining a logarithm. Suppose if a to the power of x is equal to m. A to the power of x is equal to m. A should be a real number which is greater than 1. A is what? A is a real number which is always greater than 1. Means A is equal to 2, 3, 4, 5, all positive numbers. A should not be equal to 1. Right? So A to the power of x is equal to m. Then x will be called as logarithm of n to the base a. So definition of logarithm is what? If a to the power of x is equal to m, what is a? A must be a real number. 2, 3, 4, 5. Don't take negative numbers, and it should not be equal to 1. If it is the case, then we can say that the index or the power will be the logarithm of this number to the base a. So which will be written like this: x is a logarithm of m to the base a. Hence, mathematically, it is written as, if a to the power of x is equal to m, then x is equal to logarithm of m to the base. Which is base a. So if it is the case, we can write it in log form. Suppose if it is in the log form, we can write it into the index form. The definition of logarithm. Clear? See the example. 5 square is equal to how much? It is 25, right? You just write it in logarithm form. 2 the power is equal to 2 is equal to logarithm of, which is number 25. Is base, it is 5. So this will be the base, this will be the, sorry, this will be the base, this will be the power. You'll always getting this value. 5 square is always 25. Check second example. 3 to the power of 4 is equal to 81. 3 3s are 9, 9 into 9, 81. How to write in log form? Then see, 4 will be called as what? Log of number, which is number 81 to the base 3. So 3 to the power of 4 will be always equal to 81. This is an example for logarithm, right? There are two types of logarithms. Common logarithm. The logarithm having the base 10. The logarithm having the base 10 is called what? Common logarithm. See the example. Log of 15 to the base 10. Log of 3 to the base 10. A log of 305 to the base 10. They're all common logarithms. So this was invented by Henry Briggs. Second one is natural logarithm. Second type is natural logarithm. So it is nothing but logarithm having the base e, exponential. Logarithm having the base e is called natural logarithm. See the example. Log of 5 to the base e. A log of 21 to the base e. A log of 7 to the base e. They're all examples for natural logarithm. This was invented by John Napier. This is also called Napier's logarithm. These are the two types of logarithms, right? Next important thing is laws of logarithms. We don't have derivation, just I will mention the laws of logarithms. Laws of logarithms. Log of m to the base e plus log of n to the base e is always be taken as log of m n to the base e. We can take this as log of m plus log n. Otherwise, log m plus log n can be taken as log of mn. So vice versa, it is true. Second one, log of m to the base e minus log of n to the base e is always be equal to log of m by n to the base e. Third one, a log of m, n log m having the base e is equal to a log of m to the power of n. So this index will become power n of log m n of n into log m is always be equal to log of m to the power of n. We have another law, that is change of base. Log of m to the base n can always be taken as log of m to the log of n, having common base. You can take any common base. So here what is base? N. So log of m to the base n can always be taken as log of m divided by log n, having the base is a. With this we can derive log of m base n can always be taken as log of 1 divided by log n to the base n. So these will be interchangeable. If I take the reciprocal, so what happens? Log m to the base n becomes 1 divided by log of n to the base m. So these are important laws of logarithm. Log m plus log n can always be taken as log mn, or log mn can be taken as log m plus log n. Log m minus log n can be taken as log m by n, or log m by n can be taken as log m minus log n. N log m can be considered as log m power n, or log m power n can also be taken this n log m. It is called change of base. Log m to the base n is equal to log m divided by log n, having common base. If I take base a, or you can take bb, or you can take e, anything. And with this we can derive it as log of m to the base n is always be equal to 1 divided by. If I take this reciprocal, what happens? These two will interchange. N to the base m. We don't have derivation. Just remember all these laws of logarithm. To understand how they will get, so I will show first one, proof of log m to the base e or a plus log n to the base a is equal to log of mn to the base a. So here I have taken e, you can take a, you can take b, any of base, right? Let x is equal to log of base a. You just write its index form. What is its index form? Which is base a to the power of, this is x is equal to m, correct? According to the definition of log, x is equal to log a, log m to the base a, which will be considered as what? A to the power of x is equal to m. Y is equal to log n, having base a, so which can be taken as, according to the definition of log, a to the power of y is equal to 1, a to the power of y is equal to n, and z is equal to log of mn to the base a, which is taken to index form, a to the power of z is equal to mn. Consider this is equation 1, this is 2, this is 3. So from 3, what is 3? A to the power of z is equal to mn. The value of mn. What is m? M is equal to, what is m? M is equal to a power x, correct? We have taken this a to the power of z is equal to mn. Write the values of m and n from 1 and 2. From 1 and 2. What is m? M is equal to a power x into n. What is n? N is equal to a to the power of y. So a to the power of z is equal to a to the power of x into a to the power of y, correct? So having common base, according to laws of indices, it becomes what? X plus y. it becomes x plus y. I've taken capital letters, you can take capital letters. This is z, right? We have same base on either side, only the powers are different. Just equate the powers. Equate the powers. So z is equal to x plus y. See, from equation 1, 2, 3, what is x? We consider it as log of m to the base a. What is y? Log of n to the base a. What is z? Log of mn to the base a. Just replace x by z value. Write z. What is z? Log of mn to the base a is equal to x. What is x? It is equal to log of m to the base a plus what is y? Y is equal to log of n to the base a. See, we got the proof of first law. What the first law states? Log m plus log n is equal to log m. So this is base. We can take anything, a, b, c, e, 10, anything, right? So this will be the proof. Like that, we can have a proof of other laws. So proof are not required here. Just remember the laws of logarithms, right? So based on these laws, let us work out few problems of different type. Prove that log of a to the base b into log of b to the base c into log of c to the base a is equal to 1. So what is left hand side? It is log a to the base b into log of b to the base c into log of c to the base a. Is always equal to what? 1. Let us take left hand side. What is left hand side? Log of a to the base b into log of b to the base c into log of c to the base a. You see all the each term, all are having different bases, right? The first term is having base b, second term is having base c, third term is having base a. And here the base will become the number, here the base will become number in the other term. So if it is the case, you please use the law which is having change of base. Which law we have to use? We have to use this change of base. Log m to the base n is equal to what? Log m divided by log n. We should use this law. According to this law, the first term becomes what? The first term becomes what? Log of a, right? Divided by log of b. So I'm not mentioning the base. So the base may be anything. It's not necessary to mention. A log of b divided by log of c, log b by log c into log c divided by log a. So log a into log a. One is at numerator, other one is at denominator. They get cancelled, correct? Log b, this log b get cancelled. Log c get cancelled. So all the terms at numerator and denominator get cancelled. It is always be equal to 1. Don't be consider it 0. So both numerator and denominator cancel, that's why it is 0. No, it is not at all. It is a ratio. They are cancelling each, therefore we are getting 1. Right? Second problem. Prove that log of a square to the base BC or take this one, log of a square divided by bc plus log of b square divided by ca plus log of c square divided by b ab is equal to 1. Sorry, 0. The problem is we need to prove that log of a square divided by bc plus log of b square divided by ca plus log of c square divided by ab, it should be equal to 0. Take left hand side. Log of a square by bc plus log of b square divided by ca plus log of c square divided by ab. This is left hand side of the problem. So there are 3 terms. All the terms are connected by what? Plus. Just remember the first law. What the first law states? Log m plus is equal to what? Log of mn, right? It is only for 2 terms. So it can be extended for any number of terms. It can be extended for any number of terms. See, log of p plus log of q, log of r plus log of s, like that. You can have any number of terms. The same log can be extended here also. It always be equal to log of p into q into r into s into and so on. This is an extension of first law. On the 5 laws, we can extend only this one, right? Because of having positive sign. This extended law is used for the given problem. Therefore, the left hand side become log p plus log q plus log r is equal to log pqr. Log pqr. What is p? It is equal to a square by bc into, right, into q. Q is what? B square divided by ca into c square divided by ab. To apply this law, we should have same base, common base. See, here base is not mentioned, right? It means what? All are having common base. We go to the previous example. See, here all the terms are having different bases. So there, and we have a multiplication symbol, so we cannot use this law here. Don't get confused, right? See the problem. We have applied for left hand side and extended a theorem, the extended law, first law. A into a square cancel. Correct? See the denominator. This is b into, this is also b. Both are at the denominators. This b into b become b square get cancelled. And this is c and this is c. C into c, c square cancel. What is remaining? It is log of 1. Log 1 is always 0. Log 1 is always 0. That is equal to right hand side. Right? The first law can be extended for any number of terms. Next one, prove that log of 7 to the base 3 into log of 2 to the base 7 is equal to log of 2 to the base 49 into log of 49 to the base 3. we should prove that the left hand side is equal to right hand side. Okay. Take the given problem. What is the given problem? It is log of 7 to the base 3 into log of 2 to the base 7 is equal to log of 2 to the base 49 into log of 49 base. Between the terms, what symbol you have? That is multiplication. So bases are different. Oftenly you go for change of base, right? Left hand side. See, log of 7 according to this log m by mn is equal to log m divided by log n. Use this one for all the terms. Change of base log. This is log 7 divided by log 3 into log 2 divided by log 7 is equal to what? Log 2 divided by log 49 into log 49 by log 3, log 49 by log 3. So log 7 get cancelled. Log 49 get cancelled. What is remaining? Log of 2 divided by log of 3 is equal to, here also we have log of 2 divided by log of 3. We can reapply this law. Otherwise, as it is, the left hand side is equal to right hand side, right? So if I use this law, it becomes what? Log of 2 to the base 3 is equal to log of 2. Both the steps we have a left hand side is equal to the right hand side. Next problem. Prove that 1 divided by 10 to the base 2 plus 1 divided by log of 10 to the base 3 plus 1 divided by log of 10 to the base 5 is equal to log of 30 to the base 10. Log of 30 to the base 10. Take the right hand side, sorry, left hand side. What is left hand side? It is equal to 1 divided by log of 10 to the base 2 plus 1 divided by log of 10 to the base 3 plus 1 divided by log of 10 base 5. So by looking each term, they will be appearing like this. Log of m base n is equal to 1 divided by log of n base m. If I use this law, all become common base. See, 1 divided by log nm is equal to what? Log mn. So according to that, this becomes what? Log of 2 to the base 10 plus log of 3 to the base 10 plus this becomes log of 5 to the base 10. So when we have a common base with positive sign between any number of terms, then we can use the first law. What the first law says, log m plus log n plus log p is equal to log of m into n into p. Log of m into n into p. So it can be extended for any number of terms. So according to that, this becomes what? Log of 2 having base 10, 2 into 3 into 5. That is equal to log of What is base? 10. 6. 6 into 5, 30. This is answer. We got the right hand side. Log 30 to the base 10. This is the right hand side. Or it can also be proved like this. 1 divided by a log of 10 to the base 30. Okay. Next, let us go to the other problem. Prove that 2 into log of 6 divided by 7 plus 1 by 2 into log of 81 divided by 16 plus 196 divided by 27 is equal to a log of 12. The base is not mentioned. You can consider convenience. You may consider it as log e, the base e, or it may be a base 10, right? Take the left hand side. What is left hand side? 2 into log of 6 divided by 7 plus 1 by 2 into log of 81 divided by 16 plus log of 196 divided by 27. The first term is appearing like what? This is appearing like n log m form, correct? That is taken as what? And this is also. For both, we should take them as log m to the power of n. N log m, which is always equal to log m power n. Write first these two terms according to this law. So according to this law, first two term becomes what? Log of 6 divided by 7 whole to the power of what? To the power of n. So in place of n, we have 2, write 2. A log of 81 divided by 16 to the power of plus log of 196 divided by 27. When we have square for both numerator and denominator, it becomes what? Log of 6 square divided by 7 square plus log of 81 to the power of half divided by power of half. Log of 196 divided by 27. Simplify first two terms. 6 square is 36 divided by 7 square is 49. Any number to the power of half is what? It will be the root, correct? Root x can always be taken as x to the power of half. Or x to the power of half can always be considered as root x. According to that, 81 to the power of half means root 81. Root 81 is what? Root 81 is equal to 9. Root 16. Root 16 is what? 4. According to this, root x is equal to x to the power of half, or x to the power of half is equal to root x. So according to that, 81 to the power of half is what? Root 81. So root 81 is 9, like root 16 is 4, plus log of 196 divided by 27. Now, according to this extension of first law, we can take it as log of 6 by 49 into 9 divided by 4 into 6 divided by 27. Simplify them. Just simplify them. 9 1 ja 9 3 ja, right? 4 1 ja 4 9 ja 9 4 ja 36. Correct. 3 1 ja 3 3 ja. So what is remaining? Log of 3 into 196. 3 into 196 divided by this cancels with 7 now. You check whether 196 is it cancels with 7. 7 2s are 14. 7 2s are 14. 56 will be there. 7 7 8s are 56, right? 7 7s are 7 2s are 14. 7 5s are 45. 7 8s are 7 8s are 8 5 50, right? 7 1s are 7 4s are. So what is remaining? It is log of 3 into 4, correct? So finally we will have log of 12. Log of 12. The right hand side, see, log of 12. Left hand side is equal to right hand side. Clear? Take one more problem of the same type, but having prove that 2 log of 16 divided by 15 plus log of 25 divided by 24 minus a log of 32 divided by 27 is equal to 0. Is equal to 0. Log 16 by 15 plus log of 25 by 24 minus log of 32 by 27. You take the left hand side. So left hand side is what? 2 into log of 16 divided by 15 plus log of 25 divided by 24 minus log of 32 divided by 27. So this problem can be solved in different types. The first way, you take them as n to the n into log m. You make it the third law, n log m, that become log of m power n, log m minus log n. Otherwise, first you simplify it, take them as log m plus log n, simplify it, whatever the value you will get, that will be in log. So log of m minus log of n. So even in that way also you can simplify it. First step, I will use this one. This is what? N log m. This becomes what? Log m power n. Okay. So these two will be considered as what? Log m minus log n. It is equal to log of m divided by n. Right? According to this law, log of 16 divided by 15 whole square plus log m minus log n is equal to what? Log of m divided by m. N. What is m? 25 by 24 divided by what is n? N is equal to by 27. The first term we have to simplify it, square both numerator and denominator, correct? 16 square by 15 square. Log of 16 square, I will write 16 into 16. 15 square, 15 into 15. Plus log of the quotient form is taken to the so that is equal to what? 25 by 24 into the quotient is made into product. It becomes what? The denominator they will become reverse, right? 27 goes to numerator divided by 32. See the step. It is of what form? Log m plus log n. Log m plus log n is equal to what? Log of m into n. Correct? Log m plus log n is equal to log of into 25 by 24 into 27 by 32. Cancel it. So 16 ones are 16 to the right. These two get cancelled with 5. 5 5s are 5 3s are 15, and these two get cancelled with 3. 3 9s are right. Cancels with 3. 3 3s are 3 5s are, and this 5 get cancelled. What is remaining? It is equal to log of 16 into 3 divided by 24 into 2. 2 ones are 2, 8s are 3 ones are 3, 8s are. So finally 8 get cancelled. Log of 1 is remaining. So log of 1 is equal to 0. So we have taken the left hand side of the problem, and finally we arrived at the right hand side. What is the right hand side? It is equal to 0. Next problem, if x is equal to log of a to the base bc, log of bc to the base a, and y is equal to log of c a to the base b, and z is equal to log of ab to the base c. With this, prove that 1 divided by 1 plus x plus 1 divided by 1 plus y plus 1 divided by 1 plus z is equal to 1. Here they have given x value, y value, z value separately. With these x, y, z value, we need to prove that 1 by 1 plus x plus 1 by 1 plus y plus 1 by 1 plus z is equal to 1. Sometime the same problem will be given like this. Prove that 1 divided by 1 plus, they will be given in place of x, this term, plus 1 by 1 plus this, plus 1 by 1 plus this is equal to 1. They are one and the same. Okay. You take the proving equation, left hand side. What is left hand side of the equation? It is 1 divided by 1 plus x plus 1 divided by 1 plus y plus 1 divided by 1 plus z. Right? Just replace the values of x, y, z. What is x value? It is equal to 1 divided by log of x is equal to what? Log bc to the base a plus 1 divided by 1 plus y. What is y? It is log of ca to the base b plus 1 divided by 1 plus log of z. Z is equal to what? ab to the base c. You simplify this one. Change the base of this. Change the base of each term in the denominator. So according to that, it becomes what? Log of BC divided by log A. I'm changing these according to change of base law. 1 divided by 1 plus log of CA divided by what? Log B, plus 1 divided by 1 plus log of AB divided by what? Log C. Change of base law. Next, in each term of the denominators, take the LCM. So here what is LCM? Plus log BC by log A. Therefore LCM becomes what? 1 divided by log A is LCM. Divided by what? When log A is LCM, this becomes what? Log A plus BC. Next, come to the second term. There also you take LCM. What is LCM? LCM is what? Log B. Log of B. Then it becomes what? Log B plus log of CA. Plus in the third term also, denominator, log C is LCM. It is what? Log C plus log of AB. In the next step, what we need to do? Take the simplified form of the denominator. That means what? The denominator of the denominator goes to numerator. In all the term, denominator of the denominator goes to the numerator. Then it becomes log A divided by, observe this, log A plus log of BC, log M plus log N. Log M plus log N is equal to what? Log Mn. Therefore, it becomes log of A, B, C. In the same way, next term, this log B goes to numerator. Log B goes to, numerator, log of B divided by. Here also use log M plus log N log. Log M plus log N is equal to log Mn. What is M? B. What is N? Ca. B, C, A. Or otherwise you can take it as ABC. ABC, BCA, CBA all are same, right? Plus the last term, log C goes to numerator divided by, it also becomes log C plus log AB is equal to log C AB. I can take it as ABC. Denominator of each term all are having same. Therefore, again you take LCM for these three terms, log of ABC. When we have a common denominator, then numerator will not be changed. You have to take as it is. That means log A, log B plus log C. First law, log M plus log N plus log P is equal to what? Log M N P. According to that, it is equal to log of A, B, C divided by log of A, B, C. Same terms, if they get cancelled, it will be equal to 1. This is the right answer. Okay. If log of A plus B divided by log of A plus B divided by 2 is equal to 1 by 2 into log of A plus log of B, then prove that A is equal to B. Then prove that A is equal to B. What they have given, log of A plus B divided by 2 is equal to 1 by 2 into log of A plus log of B. With this, we have to prove that A is equal to B. Let's take the given. What is the given condition? Log of A plus B divided by 2 is equal to 1 by 2 into log of A plus log of B. Take the right hand side in simplified form. I am taking 1 by 2 as it is. Log A plus log B is what? Log AB. Log M plus log N is equal to log Mn. Correct? So according to that, it becomes what? Log AB. Here I have used log M plus log N is equal to log Mn. This is of what form? This is of N into log M form. Correct? It becomes what? Log M raised to N. Log M raised to N. So according to that, this is at the left hand side, log of A plus B divided by 2 is equal to. According to this law, it becomes what? Log of AB to the power of. Log of AB to the power of. And right hand side, both are of log terms. You just taking anti-log. Taking anti-log on both sides. On both sides, cancel. Taking anti-log is what? The purpose of taking anti-log is to cancel the log on both sides. It becomes A plus B divided by 2 is equal to AB to the power of. No, we should prove that A is equal to B. Somehow we have to take the formula of A plus B whole square or A minus B whole square. Here we have, that means what? That is equal to AB to the power of, or we can write it in root. Okay. Root of x, according to this, root x is equal to what? X to the power of. X to the power of is what? Root x. I am taking AB to the power of in the root. Now, square on both sides. Square on both sides. The left hand side is what? A plus B divided by 2 whole square is equal to. Right hand side is what? Root of AB whole square. Square root get cancelled. Left hand side is of. First, you take the square for both numerator and denominator. That becomes what? AB, A plus B whole square divided by 2 square is equal to AB. Correct? Or A plus B whole square is equal to cross multiply. So this 2 square is what? 4. It becomes 4AB. 2 square is 4. 4 into AB is 4AB. Expand it. Expand the formula. A square plus B square plus 2AB. 4AB. You just take it to the left side. It becomes what? Minus 4AB. Now these two are same terms with the you can simplify it. A square plus B square. Minus 4x is what? Minus 2x. So at the same time here minus 4AB plus 4AB become minus 2AB, which is equal to 0. Look at the remaining terms. A square plus B square minus 2AB. It is of formula what? A minus B whole square, right? A minus B whole square is equal to 0. It implies that A minus B is equal to 0 or A minus B is equal to 0, correct? So from these two, we can write A is equal to B. A is equal to B. So we took the log expression that is log of a plus b by 2 is equal to 1 by 2 into log a plus log b. With that, we have proved that a is equal to b. In the same way, let us take algebraic equation and it will be proved in the logarithmic form. Reverse, we can also prove it. I am taking such problem. If a square plus b square is equal to 7ab, I am taking algebraic equation. With this, we need to prove that. See, prove that log of a plus b divided by 3 is equal to 1 by 2 into plus log of b. Log of a plus log of b. In the last problem, we took log expression and derived the algebraic equation. But here we are taking algebraic equation to prove the log equation, right? Given that a square plus b square is equal to 7ab. A square plus b square plus 2ab, it becomes formula, right? A square plus b square plus 2ab becomes formula. That's why I am adding 2ab on either side. I am taking 2ab on either side. A square plus b square plus 2ab is equal to 7ab plus 2ab. Add on both sides. I am adding 2ab for 7ab. I am adding 2ab for a square plus b square. Why I am adding? To make or to convert the left hand side into a standard formula, that is a plus b whole square. A square plus b square plus 2ab is what? It is a plus b whole square. Is equal to, it is what? It is 9ab. Correct? Take a root on both sides. Take a root on both sides. A root of a plus b whole square is equal to root of 9ab. Root of 9ab. Here square root get cancelled. It is what? Root 9 into root of ab. Correct? Root 9 is what? It is equal to 3 root of ab. I am taking this 3 to the denominator of the left hand side. Why am I taking? See the deriving equation a plus b divided by 3. That's why I am of the left side. It becomes a plus b by 3 is equal to root of ab. I am writing this root of ab as ab to the power of half. ab to the power of half. That means ab to the power of half. Now take log on both sides. Take log on both sides. It becomes what? Log of a plus b divided by 3 is equal to what? ab to the power of half. Left hand side we have obtained log of a plus b by 3 and we need to get right hand side. So to get that right hand side, simplify only the right hand side part. M over n is equal to m, that is log ab. This is equal to what? 1 by 2 into log ab. Log mn is equal to what? Log mn is equal to log m log n. That is log of plus b divided by 3 is equal to 1 by 2 into log of a plus log of b. Here we took algebraic equation and we derived the equation, right? So I'm taking last problem. Solve for x. Solve for x. Given that log of x to the base 2 whole square minus log of x to the base 2 minus 20 is equal to 0. So log square minus 5m. What is common here? M is common. So it becomes what? M minus 5. Among other two terms, if I take something, we should get again M minus 5. Then what I should take? I should take 4 plus 4. Then it becomes what? M minus 5 is equal to 0. So M minus 5 again common, right? So M minus 5 into what is remaining here? M. What is remaining here? Plus 4 is equal to 0. Right? With this, I can find the value of M. So M minus 5 is 0 or M plus 4 is equal to 0. Or M is equal to what? Is 5. Or what is M here? M is equal to minus 4. We got two values of M. Correct? We got two values of M. With that, I can get the value of X. So M is equal to what I have taken? It is log of X to the base 2. Correct? m is equal to what? Log of x to the power of x base 2. So take m is equal to 5 and m is equal to minus 4. We are getting two values of x. In first case, m is equal to what? Log of x to the base 2. So here m is what? M is equal to 5. 5 is equal to log of x to the base 2. Write this into index form. This is base 2. 2 to the power of 5 is equal to x. Correct? Therefore, x is equal to what? 2 to the power of 5 is 32. One value is 32 for x. Other value, same way, take m is equal to what? Log of x to the base 2. What is m? We obtained m as minus 4. Therefore, minus 4 is equal to log of x to the base 2. Then, the index form of this is what? 2 to the power of minus 4 is equal to x. Otherwise, 1 by 2 to the power of 4 is equal to x. Correct? 1 by 2 to the power of 4 is what? 1 divided by 16 is equal to x. So we have two values of x. One is 32, other one is 1 by 16. So such problems we need to work out to understand logarithmics in more sense. So in this class we discussed the logarithm, definition of logarithm, what are the types of logarithms, how to write the logarithmic form into index form or index form into logarithmic form. I mentioned the laws of logarithm and how to use those laws of logarithms in solving the problems. Right? So with this, I am concluding my today's class. If you have any queries, please raise your queries.